Welcome to the next episode of Project Minty, putting a Subaru 6-cylinder 3-litre engine into a 1971 VW camper. Now, I apologise for the amount of time in between these videos. I've just been so busy building things for the bus that I haven't had time to record a video. So I'd really like to update you with a few things that I've been working on. I've been disappearing into lots of rabbit holes and having a fantastic time doing it all, but been really busy and got all sorts of crazy ideas, and at some point I will need to return back to Earth and actually crack on with things. Now, if you've watched my video on my man cave or industrial unit where I store my cars and work on them, you'll know that I'm not the tidiest person in the world, so it come as no surprise to you that my workshop in here in the home is also pretty messy. But I just love getting stuck in and doing lots of things, and I tend to focus on getting the stuff done rather than tidying up afterwards. And the other thing I find is that when I've done some work, I'm often just too exhausted to clear up, or I'm too busy to clear up. So over the past couple of days I've made a start on tidying things up, and believe you me, this is an improvement, as much as it might not look so. So here is the engine wiring loom for the bus. You can see I've roughly laid it across the floor. It's the original Subaru wiring loom, mostly deconstructed. Over here we have the ECU, a couple of main relays, then the body control module, which also contains the immobiliser, more on that in a second, and the key with its inductive antenna for that. Now, one of the key things I've done over the last couple of months is hacked the immobiliser. So most people, when they run a Subaru, at least a modern Subaru, with an immobiliser and CAN bus and all that kind of stuff, they will need to include the ECU, the body control module, and also, I've got to show you earlier, the instrument cluster. Now all those parts need to match in order for the ECU to continue to run the engine for more than a minute or so. I didn't want to run all this extra wiring, I just wanted to run the ECU standalone. So I have figured out how to crack the immobiliser to remove all those extra bits. Now, for obvious reasons, I'm not going to release the details of how I've done it, but suffice to say I've done that, and I hope to offer that to other Subaru VW converters at some point in future. Oh, and by the way, although I've managed to hack the immobiliser or crack the immobiliser, it's not something that you can do to steal a Subaru or any other car for that matter. With my solution, you do actually need all the original parts of the you need the original car's ECU and its body control module and all those kind of things. You need all those things at least to be present to begin with, so that my system can understand what it needs to do in order to break the immobiliser. But I've got lots of ideas around building a test harness or something like that, where I can just plug any ECU and body control module, cluster, etc. in and then defeat the immobiliser, and then you can have the hugely cut down wiring loom. I've not finished cutting this wiring loom down, but I will do it before it gets installed in the bus. You may recall from my earlier videos that I'm building a suite of custom electronics to work in this vehicle. I'd like to give you just an update on how that's going. As you can see, there are lots of printed circuit boards and other electronics on my desk here, so I'd really like to talk you through what I've been doing. First of all, we have a bomb release control panel from a Lancaster bomber. Now that's exciting for us because we want to have an aircraft themed vehicle, and the idea is that these switches, and they're all really nice quality switches, you can open this up and see what's inside it. A bit difficult to do one-handed, but there you go. So this is the switches. This switch box is 80 years old. or thereabouts, and works absolutely perfectly. So the idea is to wire in all these switches into my custom designed body control module. Now, of course, that body control module can accept any switch input, so it doesn't need to be a Lancaster Bomber switch board. It can be anything, even push buttons or whatever you want. And here is my body control module. A couple of key things that has. It has onboard Wi-Fi and Bluetooth in this ESP32 board. It has a GPS module here, and what's clever about that GPS module is that it also works with accelerometers all integrated, so that means that if you lose GPS signal while you're driving, then the chip will extrapolate your position and still give you an accurate reading, even if, let's say, you're in between some tall buildings in a city or if you're in a tunnel. So that's pretty neat. And then it's also got on board here a 2G mobile phone data chip on it here, and space for a SIM card, so it can transmit and receive data over the internet. So that's all designed to fit inside an industry standard case. So I've got on the side over here, don't need to show you that. But I've also developed and designed a custom microcontroller board, and that's this board here. Now this has a Teensy on board, which is a bit like an Arduino, and the idea is that this is the central part of all the modules, all the electronic modules that I'm designing. It's got USB on board, and these are the main chips. It's got CAN bus for communicating across the 2-wire network on the car. It's also got LIN bus, which is a single wire transmitting and receiving protocol as well, so that can be used for things like electric windows and such like. And what happens is that board just plugs in here like so, and then you've got a 3-core, because the ESP is 2-core and the Teensy is a single core, so you've actually got a 3-core processor system for handling all sorts of functions on the bus. What this board will do also is it will send CAN bus speed messages to the ECU, so that the ECU knows how fast the car is going, which helps it with all sorts of things, including fueling and tuning, and if it doesn't have a valid speed signal, the ECU will think that something's gone wrong, and it won't let you rev the engine up to its normal red line. So I've designed that. I have also designed let me just put this in here, a lighting control module. So this is all solid state. It's able to switch high current loads like headlights and fog lights and things like that, and then that also plugs into this Teensy module like so, and that's controlled over CAN bus. So the idea is that the body control module will send CAN bus signals to the lighting control modules wherever they are in the vehicle, and they will turn the lights on or off as needed. They also have some really nice features in that you don't need fuses, because the chips used on here, they can detect open load and short circuit and shut down automatically, and also report faults back to the body control module, so we'll be able to display fault information on the dashboard that I'm also designing. Now here in this box here I've started to learn how to 3D print. So this is how I can put cases and boxes around these electronics modules, and if you see in here, there's one of my microcontroller boards inside there, fits very nicely, and then there's a hole in the top for the connectors to go in that, and that's the ECU controller. So I've designed an ECU controller which will work with the immobiliser and also read things like fuel level, the status of the alternator warning light, the check engine light, and all sorts of things like that, and then it will translate those and send them over CAN bus back to the body control module, and then onto a dashboard or instrument cluster. Also, I am working on intelligent electric windows and windscreen wiper controllers. So this is an example of an evaluation board that I bought from Infineon for evaluating their motor controller chip, and that's really interesting because I'm looking at doing single touch opening and closing of the electric windows in the van, and doing that all with no sensors on the motors, just measuring the current and other things on the motor. So I'm still currently developing that. Finally, we come to the in-car entertainment and user interface for controlling the sat-nav and other such things. So I am not ashamed to admit that I'm a huge Bang & Olufsen fan. I've got many of their products in the home, and I love their design, quality and functionality. Sometimes, you know, Bang & Olufsen is thought of as style over substance and all that kind of stuff, but actually they are pretty good. I just love the way that this control panel looks. It's actually designed for a music centre, but I'm going to use it in the bus for lots more than that. It's got really nice operation, so you can see this spinny wheel, and it spins so freely that you can, I don't know if I can do this, let me just, can you see that still rotating? So it's finely balanced and on a really nice bearing, so you can imagine scrolling through lists of music or lists of addresses, and it just, you know, just feels lovely. Buttons on here feel fantastic as well, and you've also got got a number of things. So that's just for scrolling through what you're looking at. You've got another lever here for determining what you're going to do, so that could be the major functional control. And then you've got a nice volume controller here as well. It just feels lovely to touch, and the operation of all these is so smooth. Now you'll notice also that I'm just displaying an NVIDIA backdrop on this. I've got an NVIDIA Jetson Nano plugged into this, which is essentially a Raspberry Pi, but with a graphics processing unit on board, a GPU. And what's really nice about this B&O unit is that you can just plug HDMI and USB into it, and then also on here, let me just log in here. I've got a small piece of Python code. Let me just zoom in on that. Now, as I move the dials and controls on the B&O device, you can see the numbers changing on the screen. So it's the B&O device is actually just a human input device that plugs into any computer, so you can just read the stuff straight off it. So I'm going to be writing some code to interpret all the controls on the B&O system. On the engineering side of things, I've been working on reversing the Subaru 5-speed gearbox. So this is the original differential, and what I've done is I've taken it out of the case. So this is the gearbox case. I've taken it out of the case and started to clearance the case so that I can swap that round, which means it runs backwards, thus reversing the direction of drive. So that now turns in there. I've got to do a little bit more clearancing and then put the gearbox back together. I am recording a bigger video about reversing the gearbox, but I haven't got around to finishing that just yet. I know that this video isn't my usual thing where I put loads of intro and outro and music and stuff on it like that, but I thought it better to concentrate on just the content rather than making the video look flashy. So hopefully that gives you an update about what I've been up to. I've not been idle, I've been very, very busy, which is another reason why I haven't recorded or uploaded any videos recently. I look forward to seeing you next time. Thanks for watching. Bye.